Hello there and welcome to the course. I'm Jeremy Peterson and I'm going to be showing you how you can make and sell your own NFTs. Now this is a crash course, so it will be very short and very direct. For those of you who are interested in getting more background information, I will include links to other content in the course materials. With that said, let's jump in. So what will you learn? In this course, we're going to talk about what cryptocurrencies are, what an NFT is, what the metaverse is, and then finally we'll talk about how you can create and sell your own NFTs. But before we can talk about any of that, we need to talk about something very important and very fundamental, something that underpins this entire cryptocurrency and NFT economy, and that is, what is money? What is money really? So without getting too technical, the money most of us use today is what you call fiat currency. That means it's created by government decree and it's backed by the power of a government. Often, that's all there is to it. For instance, this $100 bill here is not backed by an equivalent amount of gold or silver. It has the value of $100 because the American government says that it has the value of $100. The value of this type of money comes from laws and regulations. The government uses its powers to make sure that only the government can create and destroy money. So the government controls the money supply. Why does this work? Well, the short answer is it works because we believe it does. So remember, money is just an idea. When you pay me $100, I accept that as payment from you because I believe that other people also believe in the power of money, and they will accept that $100 from me later on for goods and services. What I'm really saying here is money is an imaginary construct. Keep that in mind as we go through the course, and NFTs and cryptocurrency will make a lot more sense. So, how is that different from cryptocurrency? Is it just that traditional money is paper and coins and cryptocurrency is on a computer? Well, no. In fact, most of the traditional ordinary money like the US dollar that's in circulation today doesn't exist as paper money. Most of the money that sits in the world's banks is actually stored as records in an electronic database or ledger that the bank maintains, not as paper. The key difference is one of centralized control versus distributed control. In order to work properly, traditional money must be centralized. A single authority, a government, creates and controls the money, and it authorizes other organizations like banks to store and manage and record that money as it moves around the economy. And you need this system to be centralized because of two key problems. Copying, which is creating new money without permission. This is sometimes called counterfeiting. And double spending, which is where you create transactions with money that you do not have. If anyone was allowed to update the bank ledger, I could go in there and write something like, oh, Jeremy pays Fred $10,000. And I could do that whether or not I actually had $10,000. So you have to have a central authority, the bank, and they have to be the only one that's allowed to update the ledger. With counterfeiting, at least for paper money, governments control that through physical force. If I try to make copies of the US dollar, I will go to jail. People will actually come physically find me and send me to prison. So you need centralized control and power to keep normal money working. Essentially, the government makes the money and the banks manage the money. So you have these two sources of central authority. What makes cryptocurrencies so special is that they solve these problems of double spending and counterfeiting without a central authority. That's the cool thing about cryptocurrency. So how do they do this? There are three key ingredients. The first ingredient is cryptographically signed transactions. When someone adds a new record to a cryptocurrency ledger, they have to sign it with a cryptographic key that proves that they put the entry into the ledger and nobody else. The second ingredient is that the ledger is a shared public ledger. It's a document that everyone can see and verify and audit. The third ingredient is proof of work, which we won't get into detail on in this course, but essentially you make people do very complicated calculations in order to submit a new record to the ledger. This keeps people from creating arbitrary fake entries. So for the system to work, there has to be a shared public ledger like this one here, where every transaction has an ID number that is unique, a sender, a receiver, and an amount. This would be the minimum information we need to get the system working. Further, every row in the ledger has to be signed by the sender. So the sender has to provide some cryptographic proof that they put this line into the ledger. So each person who's writing to the ledger has a public key and a private key. Now, this is not a cryptography course, so we're not going to go into a lot of detail here. Just know that you share your public key with other people and you keep your private key a secret. If you sign a message with your private key, people who have your public key can verify or confirm that the message really comes from you. Also very important is the fact that the signature is not like a physical signature on a check from a bank. The signature changes based on the content of the message. So it's difficult, or in fact, almost impossible for someone to come along and alter your message. They would have to generate a new signature, which they can't do if they don't know your private key. This solves the double spending and copying problems because now we can mathematically prove that number one, each line was added by the sender and not by someone else, and number two, each line is unique. We know this because when we sign the message, we include the transaction ID while we're signing it. So if you tried to change the transaction ID, you'd have to change the signature, which again, you can't do unless you know the person's private key. This gets us 99% of the way there, but we still have a big problem. Who maintains the ledger? There still needs to be a central authority or a central master copy of the ledger. How can we get around that requirement? The most obvious way to do that is to give everybody a copy. Make everybody maintain their own complete copy of all the cryptocurrency transactions that have happened. And this is indeed what systems like Bitcoin actually do. But this creates two new problems. How do we make sure everybody records the same transactions in the same order? And if there are differences between my copy of the ledger and your copy and Bob's copy, how do we decide whose copy of the ledger is the correct one, the true one? So the way Bitcoin solves this is using something called the blockchain. Basically, the shared ledger of transactions is a chain of connected blocks or groups of transactions. This is actually where the term blockchain comes from. The blockchain itself might look something like this. Every block in the chain, except for the very first block ever, has a reference to the block that came before it. And you just keep chaining new blocks onto the end of the ledger as time goes by. Now, everybody in the system needs to have a copy of the whole blockchain, the whole list of transactions, and anybody can add a block. The clever part in a system like Bitcoin is how they prevent people from adding fake blocks. And this is such a complicated subject that I've put some links into the course material. You can dig deeper if you want, but essentially, each block has a reference to the block that came before, and each block has to contain a magic number that makes the whole block come out a certain way when you run it through what's called a cryptographic hash. So you have to set up a special number that's part of the data in the block that makes the block come out of a hash function looking a certain way. And that's actually such a difficult mathematical problem to solve that it becomes prohibitively expensive to make fake blocks. You would have to have enormous computing power to do it. In fact, you'd have to have more computing power than about half of the people in the blockchain system. That is how fraud and fake transactions are prevented. All right, so with that background out of the way, let's talk about what an NFT is. So NFT stands for non-fungible token. Essentially, an NFT is like a digital certificate of authenticity. What makes an NFT different than, say, a Bitcoin? Bitcoins are fungible. Every Bitcoin in existence is equal to every other Bitcoin. They're all identical. And that's great because if you're trying to use a blockchain system like Bitcoin as a form of money, what you really want is for every dollar to be identical to every other dollar. NFTs, on the other hand, are what we call non-fungible, which is economist speak, meaning that each NFT is unique. NFTs are not identical to one another. They are totally unique little snowflakes. And this is good because what we can now do is take our NFTs and record them in a shared ledger, just like we did with our Bitcoins. Except now, each NFT has a clear, unique ID number that belongs to a particular person. So the blockchain now becomes a record of who owns what digital property. And again, we're depending on the blockchain technology here, the same thing that drives systems like Bitcoin. So the ledger guarantees that each NFT has only a single owner. Everybody can see who that owner is by reading the ledger, and the NFT cannot be stolen or broken into pieces. You can't forge or fake an NFT for the same reason that you can't forge or fake a Bitcoin. So why does any of that matter? Why would anybody want to have an NFT? That's where we have to talk about the metaverse. So what is the metaverse? Well, the truth is, nobody really knows. The metaverse is still in its infancy, but right now the focus is on building digital worlds, digital communities where people can interact with each other, buy and sell things, create things, attend events, build new things, buy and sell land, and even rent out space for other people to use. And as part of that metaverse marketplace that's evolving, people are starting to mint or create NFTs that correspond to digital art and to other digital assets inside the metaverse. That's where the interest in NFTs is coming from. It's a way to own a unique digital record that points to, say, a piece of art. Potentially, there's a big market for NFTs here, since digital items from clothing to avatars to art can all be turned into NFTs and then sold and traded within these virtual spaces. So if you wanted to go experience the metaverse, where would you go? Well, there's really no single answer. Because the metaverse is so new and so young, and because it's a concept rather than a company or a specific technology, many different people and organizations are creating worlds online that they consider to be part of the metaverse. Some of the more popular ones include Decentraland, which is essentially an online 3D event space, sort of like a game that you can log into, and The Sandbox, which is essentially an open world, sort of like a 3D world created by a gaming company, where you can buy land, build things, and share experiences with other people. So in the future, you might be able to go into The Sandbox, buy some land, set up a building, and then charge people for access to that building to see your virtual art gallery, for instance. So do you need to belong to one of these worlds to buy and sell NFTs? Well, luckily, no, you don't. All you need is a way to buy and sell crypto, an account on one of the popular NFT marketplaces, a little patience, and some money for gas fees. When you make a new NFT, it's not free. You actually have to pay someone a transaction fee for inserting your NFT into the Ethereum blockchain. And this looks daunting, but don't worry, it's not nearly as hard as it looks. Currently, there are two major marketplaces for NFTs, Rarible and OpenSea. We'll talk about how to sign up for and use both of those in just a little bit. Both of these markets will allow you to buy and sell NFTs using a currency called Ether and its associated blockchain, the Ethereum blockchain, which is where information about your NFTs will be created. And if you haven't learned anything else from this crash course so far, remember Ether and Ethereum. Almost all of this metaverse hype, almost all of these metaverse websites, they're all using Ether and the Ethereum blockchain as their underlying infrastructure. But that's enough talk. Let's go do it.